Well, good afternoon and welcome back. Thank you for coming to the CMS Applications Policy Speaker Series. This policy series is an effort funded through the NASA CMS initiative, and it's co-sponsored by the Joint Global Carbon Cycle Center at University of Maryland. For those of you who don't know, CMS is a NASA-funded project, and it's composed of 52 carbon efforts characterizing sources and sinks of carbon in the categories of land, ocean, and atmosphere. So the policy series is something that Molly Brown, Sabrina Delgado, Lucia Wu, and myself pulled together for applications. And today we will have a talk entitled Climate and Conservation. And Karen Gaffney and Tom Robinson from the Sonoma County Agriculture Preservation and Open Space District will be talking to you about tools and data at the scale of land use and decision making. We have the pleasure of working with Karen and Tom. Ralph Dubaya and I work with the Sonoma District on CMS Sonoma applications, so I'm very happy to have them as our speakers. And they are joining us remotely from Sonoma County. Thank you very much. So I'm going to let them go ahead and get into their talk. If there's any questions for Karen or for Tom, please either put them through on the chat box in Adobe, or if you're joining us over the phone, you just need to press *6 to unmute your line and then press *6 again after you've asked your question so we don't get any feedback. So without any more delays, Karen, Tom, it's all you. Thank you for joining us.
Well, thank you so much, Vanessa and Lucia. So I'm Karen Gaffney, and this is Tom Robinson, and we want to talk to you about some of the great applications that we have found for the CMS products, and just want to really appreciate the collaboration with the CMS team and with NASA and University of Maryland. So Sonoma County, where our special district is located, is approximately 60 miles north of San Francisco, and it's a very diverse county with agriculture, a large section of coast, and a lot of diverse inland areas. And the Sonoma County Agricultural Preservation and Open Space District, where Tom and I work, was formed by the community, the voters of our community, in 1990, and it's unique in the nation, and it was reauthorized in 2006 with 76% of the vote. And I say that just to note that it's a very well-supported local entity. And we are multi-objective. We focus on agricultural preservation, open space, biological diversity, water supply and quality, recreation, and urban open space. And we're funded by a quarter-cent sales tax, and that brings in anywhere from $16 to $22 million annually. And over the life of our measure, which extends through 2031, it's expected to bring in $650 to $900 million. And I bring this up because the ability to leverage these funds, even though it sounds like a lot, with additional outside funding to help us increase the scope and scale of conservation investments is very important, and the CMS products help us to do that. So we have protected about 106,000 acres to date using both fee title and easements by extinguishing development rights and helping to contain the sprawl typical of some areas further south. And all of this work, because conservation is inherently multi-benefit, has major implications for climate change, whether that's carbon sequestration or avoided emissions related to the extension of infrastructure into more rural areas, or climate adaptation. So we'll talk more about that a little later in the talk. And our conservation planning group, which is the group which is collaborating really closely with NASA and University of Maryland and the CMS program, has a lot of internal capacity in terms of spatial analysis and data to support our decision making for prioritization of land acquisition and then the stewardship of that land after it's purchased. We also use data to support reporting and messaging for our constituents to talk about how we're investing their dollars and what are the impacts of those dollars. We also use data, including, of course, the CMS data for reporting and messaging around credible metrics and how we're performing, and we use it to leverage our funding. So our funding leverage ratios often are, way more than 100%. So we'll sometimes leverage as much as 5 to 1 for our investment. And so the local applications of the CMS data are certainly to help us support land use decisions because, as many of you know, land use decisions at the county scale are made absolutely locally, usually by a board of supervisors in our case, and we tend to think about it as during their weekly meetings, which tend to be on Tuesdays, that most land use decisions in California get made by 3 votes on a Tuesday from our locally elected officials. So it's very, very important that they understand the implications both for climate change and more broadly of land use decisions, and having high quality carbon data to help them meet their, in our case, very ambitious GHG reductions goals is a very important factor for local decision makers. And in addition to the carbon implications of the work that we're doing, there are other ancillary benefits to other partners in the private sector that we'll talk about a little bit later in the presentation. One of the things that we're doing, and which is absolutely supported by the CMS program, is tracking and aligning our work at the local level with state and federal objectives, especially those related to climate change. So most of you are probably familiar with AB 32, which is California's very aggressive legislation around climate change and reducing emissions. And there is a companion legislation which is very focused on the land use mechanism for implementing AB 32, which is called SB 375. And that has a very strong nexus with the work that we do in terms of containing urban sprawl and helping to preserve natural capital and working lands and natural areas that sequester carbon and help us to avoid emissions. So this work is very important in helping us to not only align with that work, but also to gain credibility with our state agency, which is responsible for implementing AB 32, which is the Air Resources Board. So across the board, the NASA and the University of Maryland data and products help to enhance and leverage our local investment and our local decision-making accuracy, and it also helps to enhance our credibility as an organization with other state and federal organizations, and helps to enhance the accuracy of the work that we're doing. So we very much appreciate the partnership. So just some of the key initiatives, and we'll circle back to this several times in the presentation, both Tom and myself will talk about this, but these are things that are supported by this collaboration with NASA CMS and UMD, and those include, and Tom will talk about the first two, the Sonoma County Vegetation Mapping and LiDAR program, and a program that we're engaged in with the Nature Conservancy called Climate Action Through Conservation. I will talk later in the slideshow about an initiative called Healthy Lands and Healthy Economies, which seeks to document the economic and other multiple benefits associated with conservation, certainly uses CMS data. And then a whole suite of initiatives related to groundwater and land conservation, riparian corridors, which Tom will also talk about. We will be incorporating all of the CMS products into our 10-year strategic plan, which will guide our investments over the next 10 years in conservation, as well as other agency investments in Sonoma County. I'll talk a little bit later about Urban Footprint, which is a scenario planning tool whereby we hope to upload and incorporate the CMS data into that. And then finally, we're partnering with state and local agencies on kind of a multi-benefit set of planning documents called Climate Action 2020. And then all of these data and initiatives, Sonoma County has been very, very active in participating in regional partnerships that go well beyond the scope of our county, and those include the North Coast Resource Partnership, which includes about 12% of the landscape of California, much of it forested, lots of forest-based carbon, and we tend to be a test bed and then franchise work that's done in Sonoma County out to that area, and the same is true with the Bay Area in terms of their integrated regional water management planning. They tend to franchise data that are developed here and analyses and strategies, and also with something called Bay Area, One Bay Area, which is an outgrowth of that SB 375 implementing legislation that I talked about earlier for AB 32. So with that, I'm going to turn it over to Tom Robinson to talk about some of the technical implications and applications of this work, and then we'll circle back later and talk a little bit about the multiple benefits of conservation.
Great. Thank you, Karen. And thank you to NASA for this great opportunity and to Vanessa for this invitation. We really appreciate it. So yeah, I'm gonna talk about, just take some time to talk about the Sonoma County Vegetation Mapping and LiDAR program, which is a program that we initiated 2 years ago and has been largely supported by regional, local, state, and federal partnerships. And certainly the NASA and University of Maryland collaboration has been a cornerstone of all of those collaborations, as you'll see in a second. And then I'll also, as Karen mentioned, I'll touch on the Climate Action Through Conservation project that we're doing with the Nature Conservancy. And we're hoping, this is sort of an example of where we hope the CMS products will be integrated into this program. I just wanted to reiterate that if anybody has questions, feel free to post them on the chat board or just unmute yourself and chime in, in case something I'm covering needs a kind of a follow-up or clarification question. Feel free. It seems like we have plenty of time for that. So the Vegetation Mapping and LiDAR program, or we call it Sonoma Veg Map for short, again, is something we initiated 2 years ago, and its goal is to create a current inventory of the natural landscapes in Sonoma County. The data that we have currently are really meant for decisions that are made at much broader scales. And as Karen mentioned, the scale of land use change is a very local scale. Most land use decisions are made at the local level. And we believe that those decisions require high quality data and data that match the scale of those decisions. And so what I mean by that, of course, is the open space district, we need to determine whether we should work or protect one piece of land versus another. And that decision is sometimes made, if you want to talk about it in mapping scales, it's sort of a 1 to 5,000 scale or a very parcel scale, whereas our data are meant for a scale at about half our county, or about 1 to 100,000. So we're interested in, okay, there we go. Small little technical. All right, hopefully everybody can see that. Everything went blank there just for a second. But so we're interested in mapping vegetation structure, and we want widespread habitats like oak woodlands, as well as small area patches that we care about, like vernal pools that often get a short shrift in vegetation mapping. We're also interested in pervious and impervious surfaces for determining the condition of watersheds and inputs for sediment. And all of this is really, again, it's high quality data for local planning, conservation, and resource management. And these foundational data sets that are part of Sonoma Veg Map will serve conservation planning, will serve public and private land or forest management decision making, public policy development, so think of county ordinances. And then, as Karen mentioned before, the importance of messaging this work and being able to report quantitatively what conservation organizations are doing, what policy departments are doing, and how we can generate and maintain support for that, and also develop funding. So the collaboration with NASA, CMS, and Ralph Dubaya has been instrumental. What we want out of this inventory is a climate smart map, something that will allow us to model biomass, so that when land is converted from a natural state to a more developed state, we're able to quantify the loss of carbon, or the emissions associated with that. And we also want to be able to say, well, when we have avoided, when conservation or policy actions have avoided those emissions, how do we quantify that and report it? And then also, what are the ongoing sequestration benefits associated with protecting that piece of land? And again, I've got some animations in this. Hopefully this will work. Great, excellent. The data that's coming from Ralph Dubai's lab is instrumental in our ability to do that. We also, through the LiDAR data from the CMS collaboration, we're able to map habitat and model habitat, which is extremely important to us in terms of tying what types of animals will use the vegetation that we're mapping. And I'm seeing a question, does your data include accurate measures of carbon stocks in vegetation and soils? So this program, soil carbon is not part of this program, but it is part of the climate action through conservation. And I'll touch on that in a second. Great question. And looks like we have another question coming in. Well, I'll plot ahead until that comes in. The CMS data have added tremendous value in our county. The value of those data, really the NASA funding for the LiDAR, we took the money that we were starting to amass with collaborations with our water agency, the USGS, other county departments, California Department of Fish and Wildlife, City of Petaluma, Save the Redwoods League, and the Nature Conservancy, and we pivoted. Now that the LiDAR point cloud was being funded, we pivoted and created a whole series of ancillary data, of derivatives from the LiDAR data that have been extremely important to serving the consortium of agencies that you see here. The ROSES grant brought 6 federal, state, and local partners to the table, and it leveraged about $1.5 million of those other funds, the non-NASA funds, which again is just instrumental in the success of this project. And I'm seeing a question: could the data also provide information on agricultural crops? Absolutely. That's one of the aims of this inventory, is agricultural commodity as well. And I think we have I think we're going to have about 8 different classes for agricultural commodity. Thanks for that question. And again, just the LiDAR derivatives have been useful for numerous natural resource objectives. It seems like every week we are contacted by another group using the data for their work. It ranges from archaeological research, fault line research, sediment analysis, erosion analysis, watershed planning. It's virtually limitless, and it's raising the bar in terms of planning and conservation and resource management in Sonoma County. We're going to wrap up a first draft of the map. It'll be a 27 class map in fall of next year. And then in 2015, when the biomass map is finalized, we're going to evaluate that and incorporate it. And then in the fall of 2016, we're going to publish a 45 class vegetation and habitat map using the CMS canopy closure with the vegetation height to crosswalk with our state's habitat relationship classification. So we'll be able to use those quantitative data from the LiDAR to tie basically habitat preference by species to our map. So we have accurate estimates of where those species-rich areas are, and that helps with our planning. And in the fall of 2016, we'll incorporate the data findings into a 10-year countywide conservation plan. So these data, the data that come from CMS, are foundational to these inventory products, and those inventory products are foundational to our conservation decision-making over the next 10 years. So now I'll talk about the Climate Action Through Conservation program. Essentially what this is data, it's an accounting framework, and it's incentives for counties to engage in climate change solutions through conservation and land use, using Sonoma County as a pilot, which we're really excited about. It's funded through the Gordon and Betty Moore Foundation, and this is a project that we're doing in collaboration with the Nature Conservancy. It's it's a method to calculate the greenhouse gas reduction co-benefits of natural resource conservation scenarios. So for example, if we were to take a better than average projection of our acquisition activities over, sorry, there was another restart here. Let me just start things back up. If we're going to take a better than average estimate of our acquisition activities over the next 20 years, couple that with some natural resource policies that could use funding to be implemented, and then maybe add some management activities such as forest thinning for growth of larger trees that sequester more carbon and more quickly, and aggregate all those over the next 20 years, thinking that these are all activities that a county can do to make itself more resilient to climate change and participate in reducing greenhouse gas emissions. What would that look like? How would we calculate those benefits? So this is a graph that sort of depicts what we're after. Traditional climate policies incentivize renewable energy, energy conservation, and transportation. It's really hitting at those major drivers of emissions. At the same time, we know that land use, management, and conservation all have sort of positive or negative impacts on things like habitat, water, climate mitigation and resiliency, the economy, fire regimes. And so what we're interested in doing is working with the state of California, which has really shown tremendous leadership in this realm already, to develop an accounting framework that again is targeted for that county scale, that makes a link between those climate policies through legislation that Karen mentioned, AB 32 and SB 375, and incentivize good land use management and conservation decisions. So what we need is, of course, an accounting framework to serve up to the state to show how these benefits are being derived from those good land use management and conservation decisions. So I'll explain sort of how that works in a second, but foundational to all of this, of course, is an above ground carbon inventory. And that's the question before about whether our carbon stocks incorporate soil carbon. We do have soil carbon data as part of this. So I'm going to talk about the above ground carbon inventory because that's certainly the connection that we have with Ralph Dubaya and his team. But we are using NRCS soils to have estimates of soil carbon as well. But the goals of the above ground carbon inventory are to provide a spatially explicit estimate of the amount of carbon currently stored in forests and grasslands, and we've actually added shrubs as well in the county. And this is to provide a starting point for future projections and a basis for monitoring greenhouse gas emissions and reductions over time. Our criteria for the data that we use and the methodology that we use, the data need to be replicable. Certainly the idea here is that we take this framework, cookbook it here in Sonoma County, and then port it to other counties around the state. In fact, we had a meeting with a Sierran county, a county up that's located in the Sierra Nevadas, which is across the Central Valley from us. So we're having sort of bookends in terms of resource types, so forest types. And then in a week, we're heading down to Southern California to demonstrate this project to a couple of counties in Southern California, LA and Orange County. So we want it to be replicable, it needs to be accurate, and it needs to be sensitive to carbon stock changes at those activity levels. Meaning if we conserve land, we would need to be able to observe or be able to quantify those carbon benefits over 20 years due to that conservation easement, for instance. And it also needs to be cost effective. So the tool currently uses FIA, forest inventory, and land fire vegetation data. And the reason why we chose land fire is that it has historic data sets so that we can establish a baseline emissions trend line, but it also has a very high likelihood of continuance in the future.
Got a question.
Okay, great. We have a question, what about urban areas? Great question. we're seeking funding right now. In fact, we have some good news on that front, that we have funding to map urban forests. And in fact, this is an area where what we're hoping to do is use iTree, or the methods. Perhaps some of you have heard of iTree, but essentially we're going to sort of treat the urban areas differently than the rural areas, mainly because the way you account for carbon in those areas is quite a bit different. And we're excited to see what the map, with the carbon biomass estimate map that comes from the Dubai lab, shows for urban areas. I know there was a couple of plots in urban areas, but we'll be interested to see what kind of values we get there. But essentially, we want to use the aerial photography, since there is a historic data set. There's obviously historic aerial imagery that we can use to map forests, or at least canopy percent. And we have some funding for some field work to tie structural information to what we're seeing in aerial photography. So stay tuned for that. We'd love to provide this group with our report that's coming out in spring of next year, that will explain our methods. And if you all have ideas for that, we'd love to hear them, for the urban areas in particular. So this highlights the gap in our urban data. These white areas are our urban areas in Sonoma County. This is a map of our total carbon stock as projected back in 1990. And we, of course, used land fire data to basically backcast the carbon values. And we're hoping through the urban initiative, the urban forest initiative, to sort of fill in information in these white areas. But I just wanted to give you a look at carbon stocking in Sonoma County. And obviously, in this western portion, where the redwood region is, we have high values. And then in these other areas where they're mostly grasslands, there are lower values. A quick note about the baseline emissions projections. To establish the baseline trend, we revegetated areas that were converted between 1990 and the earlier land fire data set that we have for 2001 by using other land cover data sets like Landsat, TM, and our state's Department of Conservation data. So we went from 2001, did some change detection, and basically revegetated those areas that we know were converted. The CMS LiDAR data, we see this is a primary way for the CMS LiDAR data and the carbon biomass data to intersect with this program, is that it can be used to create a predictive model that can yield more accurate and precise estimates of carbon at a much greater spatial resolution. This is another look at a change. It's a change in stocking. So if we took our 2010 stocking and we subtracted 1990, this is where we're seeing increases and decreases. And again, this is how we're going to project from 2010 to 2030. This is our total. If you took the total of all of these differences, that's our baseline trend. So now I want to hone in on this positive and negative impacts and how we do this. The accounting framework basically looks like this. We map carbon, we establish that baseline emissions trend, and then we ID the drivers of emissions. So certainly for above ground biomass, we're talking conversion. Natural to residential, or natural to agricultural, or agricultural to residential. And then we identify those conservation management and policy activities that affect conversion positively. Part of that is going through a green printing process where we identify conservation priorities. That then translates into those activity scenarios where we take acquisition plus policy and management, and we show the resulting change in carbon. At the same time, we want to show those conservation co-benefits, for instance, groundwater recharge wildlife habitat connectivity, and so forth. So we need to model activities. So avoided conversion. We need to figure out what could have happened if we didn't take those actions. What about opportunities for reforestation? How would we sort of model reforestation? Improve forest management, urban forest management. These are things that, projecting from 2010 to 2030, we want accurate and credible ways to model these activities. So just to bring it way down onto the ground, this is the LiDAR data that we received through the CMS program of a confluence of two creeks, and you can actually see. Let me see if I can use the pointer tool here. Oh, here we go. So you can see the historic floodplain of this creek in the LiDAR data. You can see it here, and then let's advance one slide, and all of that has been planted in grapes. And so the riparian forest has been sort of confined to this narrow strip right here. So what we're interested in is essentially modeling this across the landscape and quantifying the greenhouse gas benefits of doing this in strategic locations. So it's just a look at what we're talking about doing. Literally paying this landowner to back off the creek and pull some of the vines from the creek and allow this forest to revegetate. Here's another look at what we're talking about, where we have the edge of the true, here let me use the green arrow, the edge of the true riparian corridor. And here's the edge of the existing riparian policy protection in this dashed black. What if we were to enact a county policy that moves this black line closer to the edge of the riparian corridor? This is a policy that would take quite a bit of money to implement. And we would then get something that looks like this, where through the policy work, in addition to the conservation work, we might see more riparian vegetation in our stream areas, our riparian areas. I mentioned that the framework includes a green print, and I won't spend too much time on this, but basically what this is it's analyzing those areas that we deeply care about, things like food production, water, ecosystem services, terrestrial habitat, and stacking them on top of each other and finding those areas where we get a big bang for our buck. And we use that information to incorporate into our scenario planning. I see that there's a question, are the maps based on small footprint LiDAR data? Small footprint, well, if you mean extent, the LiDAR data are for the entire county. And then in terms of scale, it's 8 points per square meter, so it's a very fine resolution. Hopefully that answers your question. If not, please chime in. This is ultimately what we'd like to report to the state. This is really showing how all of this works. This is the do nothing, the business as usual scenario. Green along the bottom here, this is our net reductions and removals. The baseline is in blue and the scenario is in red dashed. The business as usual scenario is the baseline scenario. Now if we were to add the ceasing the conversion of grasslands and shrublands into agriculture, we see a slight bump or a slight increase in reductions or removals of sequestered carbon, and we see that in this scenario. And then if we couple that with thinning redwood Doug fir forests from below instead of removing dominant trees, and we get we're basically growing larger trees, we get a big jump. And this line here is what we would report to the state as our greenhouse gas reductions through these activities. So the timing for this project we want to complete our project report in the spring or summer of 2015, verify our inventory assumptions, assess uncertainty of inventory and projections, And as I mentioned, ongoing, we're continuing our outreach for additional county and regional pilots. So with that, I'm going to turn it back over to Karen, who's going to talk about the multiple benefits of conservation, the underpinnings of this work.
Great. Well, thank you, Tom. So we have been working with our community and our decision makers to really convey to them that conservation is actually quite a unique tool for addressing climate change because it addresses, as Tom has demonstrated, so many benefits and multiple objectives. So, for example, hybrid cars or building retrofits are usually fairly single objective, and conservation has multiple benefits. And so we're really, with a grant through the Gordon and Betty Moore Foundation and the Bechtel Foundation and the Coastal Conservancy, have a very large 3-county initiative focused on this question of how conservation can be cost-effective in achieving multiple goals, how it might be more cost-effective over time than more built infrastructure approaches, and how it helps us achieve goals like emissions avoidance, carbon sequestration, but also biodiversity, human health, food security, water quality, and supply. So we're doing a lot of work, as Tom demonstrated, to integrate biophysical data with socioeconomic data to really paint a full picture of quality of life and why conservation of natural capital, working lands, and natural areas is critically important to our quality of life and probably critically important to achieving our climate goals. And so we find that framing the discussion in this way really impacts and has relevance to our decision makers. So in a way, if we can kind of pull along our climate goals under this multi-benefit context, it's more likely to land with our decision makers and our funders and the public, and it helps us to then leverage that local investment that we have the luxury of having. So having the NASA and University of Maryland collaboration helps us to really enhance the accuracy of these multi-benefit analyses and is, again, foundational to their credibility and their success. So I'm going to give a few examples. So this initiative, Healthy Lands and Healthy Economies, is a 3-county initiative with Santa Clara County, Sonoma County, and Santa Cruz County. And we're basically monetizing the multiple benefits of conservation so that we can basically tell, for example, our Taxpayers Association that actually conservation is a good investment. And the CMS data and products are foundational, as I mentioned, to this initiative because it provides decision support both locally and statewide. And by that I mean, for example, that it's influential in California-wide policy and legislation. So we just recently, a couple of weeks ago, passed a water bond, which is billions and billions of dollars for investments in watershed protection and water infrastructure. And that Sonoma County and many parts of the state, including the Sierra and the North Coast, are making a strong argument for why natural capital will make us as a state more resilient to fluctuations because of climate change and drought in our water supply infrastructure, and that it actually makes sense to have these source watersheds protected as opposed to having a situation like we have in LA where it's almost entirely built infrastructure. So these data and this initiative, when combined together, have been influential in the water bond. We've used the partnership to help to influence some of those decisions. Certainly in terms of AB 32 implementation, we have a whole Working Lands Coalition that has strongly influenced AB 32's rollout in terms of making investments in agricultural lands and working lands in order to achieve our climate goals. And then down at the local level, I want to provide an example of how this initiative, coupled with products such as those coming out of CMS, has resulted in a measure passing in Santa Clara County, which is where Silicon Valley is located. Measure Q just recently passed, and it passed fairly closely, and the data from this initiative characterizing the multiple benefits, including carbon sequestration and climate benefits associated with conservation, was absolutely instrumental and probably the tipping point for that measure passing. So,
which is a land conservation
measure. Yeah, thank you for that. Yeah, it's a measure to invest in additional land conservation through the Santa Clara Valley Open Space Authority. So just a couple of quick examples of this multiple benefit approach that really lands with decision makers. Our local electeds care very much about achieving AB 32 goals, and they have actually more assertive goals for emissions reduction than even the state of California does. So we have very enlightened decision makers in that regard, but it's important for them to have a lot on their plates to understand that conservation investments basically are carbon plus. So here's an example of Cooley Ranch, which is one of our larger conservation easements, which protected a quarter of the Lake Sonoma watershed, which is a drinking water supply for 600,000 people in 3 counties. And so in addition to protecting that watershed from a carbon standpoint, there's a lot of carbon being sequestered in this watershed, and we can document that through the CMS program. There are all these additional benefits in terms of water supply and water quality, but also avoidance of habitat fragmentation, impervious surface and groundwater recharge protection, recreation and public health, riparian corridors, et cetera. So you can see here on the left, there's a picture of the before condition when all of the development rights existed on the property and there was a high potential for fragmentation and removal of habitat and extension of infrastructure. And on the right, we reconfigured that property through a conservation easement, which reduced the building footprint down to just a few acres and allows for continued agricultural production as well as recreation, but also protects the riparian corridors and protects the sensitive recharge areas of the property. So just an example of how carbon documentation can work together with other benefits to help decision makers understand the benefits of investing in conservation. Here's another example of what we're calling Carbon Plus. This work that you see here, there's a corridor depicted that was documented through the Bay Area Linkages Project, which is trying to achieve habitat connectivity across a large regional landscape of multiple counties. And that certainly supports biological diversity, and it helps species adapt to climate change by giving them places to move to and have dispersal corridors. And it helps, of course, with natural capital resiliency. But in addition, that particular linkage, which you see mapped here, sequesters a very large amount of carbon, over 63 million tons. And so we want to tell the story of the carbon benefits as well as these other co-benefits, including scenic, recreation, and water quality and supply that accrue to conservation investments. And again, the CMS data are critical for that. And then finally, Tom and I are meeting this afternoon with NOAA and Stanford University and the Ocean Protection Council to talk about a project that we're working on with those groups, looking at coastal resiliency. And with sea level rise, we're doing a lot of work modeling flood risk and sea level rise and storm surge as it may impact these coastal communities and up into the Russian River, which is the area you see in the middle photograph. This is the town of Guerneville, which has one of the highest flood recurrence intervals in the United States and has been the subject of a lot of FEMA disaster money, and it's influenced certainly very strongly by sea level rise. And so we want to be able to tell the community about the benefits of coastal natural capital investments and how much carbon is being sequestered in coastal areas. It happens that forest-based carbon in coastal areas through the redwood forest is very, very high, but also to be able to talk about those coastal investments in terms of enhancing green infrastructure and our resiliency to sea level rise, in addition to having all of the other benefits that we've emphasized over and over throughout this presentation: recreation, terrestrial benefits for terrestrial and marine habitat benefits, tourism, et cetera. And then finally, there's a strong emphasis through the programs that we have here at the district on not only integrating and talking about multiple benefits, but really using these data as an opportunity to convene multiple sectors. And so we really see the CMS products, LiDAR in particular, as being a convening tool which has brought together multiple sectors and has helped us as a community think about multiple evolving applications. So just quick examples, CAL FIRE is using these data to quantify carbon for their grant evaluations, but also to look at fire and fuel load modeling. The Sonoma County Water Agency is very interested in catastrophic wildfire. We recently had a huge fire in the watershed that supplies San Francisco, and there are just major consequences in addition to emissions also on carbon impacts on their water intakes, and it will cost the public a huge amount of money over many, many years. And they're also interested in emissions and carbon reporting for their stream maintenance program and looking at groundwater recharge and for uses related to hydro modeling. We also have been working a lot with our Farm Bureau and private sector folks, and a lot of applications for them in terms of carbon projects or engineering firms or restoration ecologists. And there's been a real benefit to these private sector groups in partnering with a public agency such as ourselves, because we can provide these data out to these groups and lower their costs and enhance the quality of their projects. And then finally, we're really excited about an upcoming application of some of the CMS data, which is that we received a grant to use a scenario modeling tool called Urban Footprint, and we're also going to be incorporating the CMS tools into our decision support system called EAMS, and basically using these data to work with all the sectors, residential building, the water agency, transportation, and others, to tell the story about how conservation fits in with and mutually benefits and augments the emissions reduction strategies of those other agencies. So it's been a real opportunity. It's been a very strong convening tool to have these LiDAR data and to work with them in these multiple applications to have a comprehensive approach to emissions reduction in Sonoma County. And I'd like to close by saying that it has been an incredible opportunity for us as a district, but also for these other partner agencies and NGOs and private sector groups for capacity building, and we expect it to have long-term benefits. So with that, I think we'll close the presentation and just acknowledge our many, many partners, and thank you again to NASA and Ralph Tobias with the University of Maryland.
Karen, can you hear me? Probably not.
Yes.
Perfect, great. Thank you so much for that. We're going to take some questions now. I know some people are typing, but does anybody here have a question? They can read the chat box. Wenji? The slides will be available online, and for anybody that was suffering from the feedback, the recording's available online as well through the CMS website. So I'm sorry about that at the beginning. Let's see. Any questions in here? Could you give them a mic, please? Thank you. I'm just making sure they can hear you. We'll hear you and you're fine. Oh yeah, sorry about that. Go right ahead.
I was just curious about how you're targeting for the riparian reforestation. How you're choosing where to reforest. Is it just opportunistic? Are you trying to look to maintain sort of a uniform corridor on both sides of the river? What scales are you thinking about? There's a lot of different ways to do it. I was just curious. It seems like a really neat idea.
Well, I think we have, we'll probably both respond to that. Ideally, we've got some historic change detection data about the impacts to riparian corridors, especially the alluvial riparian corridors, which are most impacted in California and also in Sonoma County. So we've lost, in some cases along the Russian River, for example, about 95% of the historic riparian extent, and we know that between 1940 and 1990, for example, we lost about 50%. So certainly looking at historic data, but Tom, and he can talk about this, is doing some interesting modeling, looking at projecting the functional extent of the riparian corridor, and so when we have those data countywide, we hope to be working through demonstration projects with local landowners to ask them whether they'd be interested in an incentive-based program to expand the corridor out into their existing land use, and of course have us, pay them through some sort of an easement program.
Looks like we have a question. Could you elaborate more on climate smart modeling? What kind of models are you using? I think that urban footprint, if you haven't heard of it, it's worth Googling and checking out. And I think essentially, as Karen was mentioning, it's a model that it's a scenario painting tool that allows you to paint various urban growth scenarios. But we're working with the folks who put this model together to incorporate a rural end of this. So as we paint a sort of a climate smart urban growth scenario, what does a climate smart rural scenario look like as well? So keeping our rural area intact has benefits to groundwater recharge, has benefits to agricultural productivity and food security. It has benefits to wide-ranging carnivore movement, which keeps prey populations healthy and more resilient to the effects of climate change. So I would say urban footprint and our modeling tool that we're developing with the Conservation Biology Institute called EAMS. Great question.
Any other questions? Okay, and I think we're good from people online. Again, the talks for all the CMS policy series, especially this talk, they're all available through carbon.nasa.gov. And Karen, Tom, it is always a pleasure to have you. Thank you so much. That was a great talk. We'll continue this, and I appreciate you guys sharing so much. This is it's really enlightening when we get to see this side of the carbon product application. So thank you again.
Thank you all.
We'll be talking to you guys soon. For next week, or excuse me, for next month, we do have the RGGI program, or the RGGI initiative. So the Regional Greenhouse Gas Initiative, Maryland Representative Marissa Palcic will be here. If you'd like to know more about RGGI and Maryland's role, please feel free to join us for the policy series. It'll be on the webcast, and again, the slides will be available online. Don't hesitate to recommend speakers if you'd like to hear somebody in the future, and thank you all very much for coming. Take care. Thank you, guys. Bye-bye.
Thank you.
And please eat the food. There's a lot of food left.